All right, Jay. First of all, thank you so much for buying my book. Oh my gosh. Go on Amazon, give me a review. Okay, so local storage versus SAN. Okay, first, high level discussion. Every word of this screams there's no way SAN should ever have been considered, ever. So let's be clear, there isn't any but there's this thing. Every single word, from what happened in the past to what your dealer is saying to what is happening in the future, every person involved is giving you the information that no SAN should ever have been considered. That also means the company who's lying about being an MSP, the salesman, they should be fired. I mean this. There's no candy coating this. These people are crooks. They're lying about being in IT. No IT person could ethically say this is violating every bit of ethics in IT. They're lying about being in IT. They're lying about looking out for your needs because the word IT means they work for you, right? They represent the needs of your business. That is exactly what they're not doing. They are acting like used car salesmen who see someone coming. You're like, you need this car. Right? Oh, I came in for a bicycle. No, you need a car. I don't have a license. It doesn't matter. You don't need a license. Right? That's what's going on. These people are crooks. They are not your friends. They do not represent your business. And on a security basis alone, I would walk them out the door and say, these people are social engineering us, because what they're trying to do is not just sell you something you don't need. That's the job of a salesman. They're doing so in a dishonest way, in a way that puts you at risk, not just that wastes your money. Right? That's what a Chevy dealer does. You could get by with this little, Chevy Spark, but you could come off with a Corvette. Well, the Corvette's not going to kill you because it's safer than the Spark. It runs, it'll get you to work. They're just trying to get you to spend more money. That's what a good salesman is like. This is a salesman who's like, I can make some money and put him out of business. That's who this is. This person has to hate you and your company. Has to. No one who just kind of like you could do this to you. Okay, so that's where we're starting. These are evil people, not just bad people, not incompetent people, not kind of dishonest people. These are really, really rotten people to suggest a SAN where it has no case, where you're saying you need for exactly the opposite. Okay, so that's our starting point. They are a reseller. Never call them an MSP. Don't empower their lies, right? They are deceptive salesmen who are trying to take advantage of you getting marketing from other sources that tries to push a SAN, which nothing has done in 10 years. So I'm really surprised that you're hearing this, that people are still talking about SANs. This is a long dead thing. Okay, so our first thing is looking at your stuff. We got to figure out what your goals are. And that's never really stated, so we have to pull that out of here, right? And we can respond and talk about what your goals are, but your goal thinking is really critical here. We got to figure out what that is. Now, we're going to go back and read some of the things that we feel we know from this. We'll read the whole thing, but okay, so one of the things, you only have a handful of VMs, so you don't have scale. That rules out a SAN. SANs are only for scale. You have a file server, SQL server, free PBX, inventory management system, security server, internal apps. Okay, so of those, are any of them truly mission critical? You say, for the most part, we can afford some downtime in the event of a host failure. So first of all, your in-house app should not have any risk from that. If it's made in-house, they should have made it with high availability because that's how modern apps are made. With rare exception, there should be no problem. So that shouldn't even be on your radar. SQL Server also has application level high availability, so it shouldn't be on your radar as a problem. Free PBX can be migrated just like that. So again, you would lose your in-flight calls, but it shouldn't be a problem. You don't need high availability for a phone system unless you're like a 911 call center. And even there, I can tell you, they don't need that. That's not something they're required to have. Inventory management, I don't know how that could be important in that way, but maybe. Security system server, never seen one that had to be that high availability ever. Those two, the inventory and security, are so generally far from high availability that you would never discuss it. All your other workloads have high availability where they go at the application layer. Like real high availability is always at the application. And so of all these things, the only one that maybe, because we don't have any information about it, might need high availability and doesn't provide it itself is the file server, but most file servers can do that in an application. So I don't even know what workload we're looking at here for maybe high availability, and you say you can pretty much survive without it. So all of that tells us you don't have even a discussion point for high availability. And then we go back and say, from what I can tell, in the past you've had a SAN, and right now you're considering a SAN. If a sand was okay before, and if you feel a sand is okay now as options, you've ruled out high availability. So we know we don't need it, right? So as a goal, we know high availability isn't on the radar. You have no workload that suggests a purpose for it, and you have existing infrastructure and proposed infrastructure that rule it out. So that's a starting point. We have to assume that we can read into this a little bit. Your goal is a non-high availability system, right? If you need high availability, everything we've talked about goes out the window, because you can't have a SAN for high availability. You can have multiple SANs, but then it still wouldn't make any sense. You don't have a reason to go that extra cost and risk, but you can't have a single anything and do high availability. That's the definition, right? And I guarantee this scum who claims to be an MSP is probably using the incredibly worn out and very obvious lie that, well, our SAN's high availability. It's just magic. It's high availability in one box. Really, so a SAN, which is just a server with storage, is magic and high availability without needing a SAN of its own. How does it achieve this high availability? Well, it has redundant components. Okay, instead of a SAN, get me a computer that has those redundant components, and I don't need the SAN to do that. Well, you can't do that. Really? Because you just did it with the SAN, and SAN is just a computer. There's no magic. So if they can say it about the SAN, we can say it about not the SAN and eliminate the SAN again. So whether they're saying a SAN is high availability on its own or not, in either case, it rules out the SAN, right? Basic logic just knocks it out. So SAN cannot play there because it's just a server. But we know it's an EMC, right? So we know it's not a bad SAN. EMC doesn't make bad SANs, but they also don't make really good ones, right? No one makes really good ones because it doesn't make any sense in the market, because SANs did have a really big purpose long ago. Now, everybody buying SANs. There's some exception somewhere. You're not it. I'm not it. No one I've ever met is it. Somewhere there is somebody who needs a SAN for a very specific purpose on a large scale. And there's somebody still making a good SAN for them. Across the board, all this stuff is crap, right? Because all of it exists for the purpose of defrauding IT departments via scummy salespeople claiming to be IT. That's the universal path to getting the stuff out there. And they often go directly past IT and go to managers so that they don't get questioned on all the complete lack of logic in their stuff. All right, so let's start with, okay, we're planning on a server upgrade. Find myself faced with the question of whether a SAN is necessary. No, your question is, how could it be considered? What your question should be, do I need high availability? Right? Your goal is to create a great system for your company that meets its needs. Sub-goal, we need a system that is cost-effective, fast, and reliable, appropriate to the cost threshold and recovery thresholds that we have, right? What we know is that you don't need high availability. It's ruled out in this discussion. You'll hear as we go through many points as to why, but we know you don't need high availability. We're really confident in that. So, and we also know that SAN isn't necessary. You have no points that even make it viable, let alone necessary, right? There's nothing that it plays well with. I know there have been many posts, both here and on other forums, about SANs being oversold in situations where they are not needed. That is not a good way to word it. SANs are underperforming. They're not overperforming. This isn't selling you more than you need. It's selling you less than you think you're getting. The whole thing, it's not just that it's expensive. That's when they get caught in the lies, that's what they start going to. Well, I know it's expensive, but I think you need it. No. Yes, it's expensive. That's not the problem. It doesn't meet the high availability needs. It lowers the availability. That's the problem. The person you sold it to was told they were getting high availability. They were lied to. That's the real problem. Okay. My gut instinct is that this situation is one that really doesn't require a SAN. Yet, I still find myself unsure, shouldn't even come up as a question, that I understand the various questions that I should be considering to make that decision. There's nothing to ask. Like, for real. If you need a SAN, this is the rule of thumb, and it's in the book. The rule of thumb with a SAN is, if you need it, nothing else works. If you can build the solution without the SAN, you must. There's no situation where you want a SAN. There are very, very niche situations, and they get less every day, where a SAN is the only viable option. It's been a really long time since I've seen one of those, but they do exist. I'm not going to pretend that it could never ever happen. It has happened in the past, but it's never something you want. You always engineer away from a SAN, and if you fail to be able to engineer away from a SAN, okay, you may get stuck with it. So you never have to ask a question. You never need to wonder, can I build this solution without the SAN? Oh yeah, I can. Done, right? Ruled the SAN out. Or the better thing is never consider it, right? It is safe, very, very, very safe, and has been for a very long time and only safer into the future. There's not going to be a situation, there's never been in the past where you should have had a SAN. You should not have had a SAN in the past. A salesman took advantage of the situation in the past, but not as much. Like, it gets worse as time goes on. As time moves forward, we're already in a no one needs to consider SAN world, and have been for quite some time, and it's becoming a more and more insane that anyone would think they could get away with bringing it up. And that's where we are now. That this EMC sales goon thought he could get away with giving this as a proposed solution is unthinkable, right? There is no ground he has no plausible deniability that he's so clueless in the industry to think that he could say that and not get called out. Okay, bought a chapter, reading the stuff out. Yep, read the book, cool. Okay, our needs are not sophisticated. We only have a handful of VMs, all right, low volume, good. We already talked about what they are. For most of these, we can afford some downtime. The exception is really the SQL server. While it would be not be catastrophic for some downtime, it would be far superior from a continuity perspective if it could fail over to a secondary host if necessary. So this is where you need to dig in, right? You really need to look at the SQL server and sit down. This is where, as a CIO, you may not have the tools at your disposal to answer the question. You should have the tools at your disposal to ask the question and to frame the question, but you may need a CFO to answer the question. And so this piece is really important because this is what determines not if you need high availability, but can you consider having two hosts? Okay, that's where we are. Can you consider having two servers? Because everything else suggests probably not, right? Suggests, you might, but it suggests probably not. The SQL server, maybe the downtime of SQL server is going to impact you enough that you need to have a second host. Completely acceptable answer. So let's talk about it. You need to figure out what happens when SQL Server dies, and you need to do so only in the context of when it dies from hardware. Everything we're talking about here, we have to frame this, is your physical infrastructure. This is not where your high availability is supposed to live. It is not it's not the entirety of your stack. It is one piece in the middle. It's a big piece, but it's one piece in the middle. So if SQL Server was to have a bug and fail, this doesn't address that, right? If SQL Server was to have a configuration error, this doesn't address that. This is just if your hardware fails. So if your hardware fails, what is the chance of that, right? Most servers are about 5 nines. So you expect one brief replacement failure every 10 years. It might be 4 nines. It's a really, really big number. And SQL Server, how much would you lose in a catastrophic hardware failure event involving SQL Server? And that's the number you need to get from your CFO if you don't have it, which you probably don't. So you're seeing your CFO, and he's gonna tell you that's $100 an hour, $1,000 an hour, $10,000 an hour, and whatever that number is, that's gonna give you an idea. Now say, if I don't have a second server, how much time do I get to recover? Okay, and so let's say that you have an outage event and it's $1,000 an hour because it's an easy number to work with. Say, okay, I don't have a server. I can recover my SQL server to a server we run out and buy, to another piece of hardware we just happen to have, to a cloud instance that we spin up just for recovery. Do some planning here, and chances are your recovery is a few hours, even with no plan, no physical replacement, right? Having a plan's good, and even then, you just have to have a triage person. That's what triage people are for. They deal with things when they catch on fire, because there's so many unknowns at that time. Okay, so now 4 hours, we're gonna have it back up and running on cloud. I work for a bank, and they make this exact same argument. We have no failover because we can go to cloud in about 45 minutes. That they don't lose enough on the workloads that they run to justify paying for everything to be redundant, because we can spin up completely fresh cloud instances in under an hour, move the workload, get the servers replaced, shift it back at some time when it's convenient, right? Next day, next week, whatever. So even big banking things, financials, may just be like, oh yeah, we could just switch to cloud if we had to. We don't want to. We don't want to do it day to day. But in a catastrophe to keep us from throwing money away, yeah, all over it. Maybe you can't do that. Maybe you have to have it physical. Maybe you live in a place where you can't get another server in less than 3 days. Easily, you need to have a second server, but easily you don't. So run that number. Always use math. Math is the only thing. If you don't have a number that says you need to do it, assume you don't. Right? The default should never be high availability. That is a niche, a very expensive niche that is very poorly understood. You should always default to normal workloads. 90% of workloads or more, 99% maybe, need to just be a single server, single workload with good backups. That's it. Recovery is so easy when other things are done well. And the entire need for high availability at this kind of level where we're talking about like a redundant SAN only applies to when things aren't done well. This isn't a good way to do availability when you do need it. So any of this, this is not the right layer, right? So we're gonna talk about that. So if you decide you do need that second node for SQL Server, then almost certainly you need SQL Server to be creating redundancy between them. So you can't use a SAN, because not only would a SAN not give you what you need, it would actually break the high availability that SQL Server is providing, right? It would take the two copies that SQL Server does to protect you and it would merge them into one. It would actually do all the overhead of redundancy and then remove it just to screw you over, right? That's not why they wrote the software that way, but that's what it would do, because it's like living in a glass house and taking a hammer to the walls, right? It's going to break, but they didn't make the hammer thinking people would do that, but they do. So your SQL Server, just like Active Directory, which relies on SQL Server under the hood, and other truly high available workloads get completely hosed when people put SQL Server or put a SAN behind them, which is one of the reasons why those salesmen are so icky. They can't be so dumb as not to know how their product works. They have to know that it's taking all the storage that's supposed to be redundant and merging it into a non-redundant system. Okay, so SQL Server is covered. If you need it, and maybe you do, SQL Server takes care of it, which should also handle, like we said, your free PBX. It's a little bit different. Free PBX is not going to give you a real time. It can, but in general, it's not going to give you real time. Just keep a copy of it. It's that simple. So it acts like a manual RAID 1 in that case. No big deal at all. You can automate that, ship it back up over every night. Yeah, you're gonna have some downtime, but only enough time to turn it on. Like, it's really fast. Okay. Your internal applications, make sure that they're redundant. Whatever. All those pieces, just do them right with 2 nodes, and you should have basically way better high availability than you need, and certainly better high availability than you've ever had before. Like, you'd actually have high availability with redundancy rather than fake high availability with no redundancy, right? So, okay. So we're already past, like, all of this is moot. You don't need any of the things you're worried about, but you do need to do the pieces we're not talking about well. But that's a given, right? You always have to. You can put anything in and not take backups and lose it all just because you're being dumb, right? Still take backups. Okay, with that in mind, I had planned for 2 hosts so we could survive the failure of one of them. That's not a bad way to go in most cases, but you do need to run the math. Just be sure. Does it justify the second host? If it does, fine. My primary confusion, though, is how to accomplish replicated local storage. You don't, right? If your workloads are good, you don't want replicated storage. Replicated storage is for when you're overcoming bad applications. SQL Server is not a bad application. Free PBX is not a bad application. Your inventory management I can't speak to. Your security, who cares? If they're caring about that, question some things. Internal applications had better be high availability or you need to deal with some problems. File server maybe, right? But replicated local storage shouldn't be something you want. It is a proper tool when you have to fall back in the situation where you do need high availability and your applications suck. Why do you have applications that suck if you need high availability? That's a question you need to ask the IT, like everybody involved. Who put in applications that have this need and don't have the capability? Like, clearly a mismatch, but that is a space where people fall. Now you're going to wonder, but I hear everyone talks about this. Yes, incompetent IT departments universally don't know how to properly run their own applications and systems, and they go to this as a failover kludge or crutch where they can go to management and say, we have high availability. It's not what professionals mean by high availability, but it's something, right? It's there for fudging it, and it mostly works, but it's not the same at all. And it is an important tool because some people are forced to run applications. Lots of people are forced to run applications that don't have high availability options. QuickBooks. Do you run QuickBooks? You don't have high availability options unless it's on a file server that's going to handle it with some care. So if you have QuickBooks and you need to have some like really fast, real-time failover, yes, put it on DRBD, good to go, right? Is it as good as if you had a proper system designed for accounting or finance? No, that would be way better. But given that you have a toy made for children, QuickBooks on DRBD will work. Right, but the fact that you need DRBD or similar to make QuickBooks have the option of high availability tells you a lot. One, well, what Intuit thinks of people who use QuickBooks and what the people who selected QuickBooks think of their company, and what accountants think of their careers. So how would you do RLS? Yes, if you determine you need RLS and the stuff you have suggests you don't, then it's probably only the file server that you actually want to do on that. And you would create a separate space, probably an LVM, for that and let it ship for that. And the rest of your workloads be independent. You don't want replicated local storage except as a fallback to good applications. So your SQL server should be on local storage, no exceptions. Always. There's no time that SQL server should be on replicated storage of any type, on SAN of any type, ever. And like FreePBX, again, just keep copies. Like look at each workload. High availability is always something you do. It's not something you buy. It's always by workload, never as a blanket thing, because every workload is different. You then asked the question, I would think that these have to run in the hypervisor and not as separate VMs on the host. Is that correct? It is, it's true but not correct. Generally, those are going to run at the hypervisor level. And good hypervisors either offer that or build it in, like offer it like you could do it, or build it in like they do it. So if you're building your own KVM, you could add those. If you're doing your own Zen, you could add those. If you're doing Proxmox, at least 2 of those are built in. DRBD and Ceph are just part of the Proxmox thing, and you can manage it through the main console. Again, you wouldn't normally do this, but you can. And DRBD is just RAID, right? It's network RAID, really, really basic and very functional. Ceph is much more complex, but good for really large scaling. You're only looking at 2, so DRBD, of these technologies, DRBD is the only one on your radar. So the question is, do you need DRBD or not? Nothing else. But the answer is, can they run as separate VMs? Yes, they absolutely can. Probably don't want to, but there's situations where you would. And one of the times that you do that is if you were to make the mistake of having VMware, which doesn't support the things necessary for a production environment. So you have to fudge it by putting, you have to do things in a really crappy way to get VMware to run more or less like the big boys, right? But VMware is really, I mean, remember, they were owned by EMC. So they are basically a sales platform. They have all these like missing pieces and lots of gaps for the purpose of making the SAN look viable. So the salespeople that sell the VMware are the same ones that did, now they're separate, but they used to be the same ones selling the SAN. So they were in collusion because they were one company, just different divisions, and they made the products to go together so that they could sell something worth many, many, many times the cost that didn't work as well as something really simple. So that was a very orchestrated deception by both players, who are one company, right? There's no like big collusion. There's one company trying to make money. Okay, in general, for relatively small environments such as mine, is it feasible to even attempt local storage replication? If you need it, it's feasible. You can do it on a desktop, right? You can do it anywhere. Intel NUCs, like Scale sells these systems on Intel NUCs, right? Like there's no too small for replicated local storage. There is, I don't need that particular niche of high availability almost everywhere, but there's no size level where you would have to consider it or not consider it. If you We're a tiny company with one server and one workload, but it didn't have application level failover, and it did have a need for high availability. You'd be a candidate for DRBD, even though it's one tiny workload. Given that DRBD is so cheap, that really makes it that everyone falls into that category. As long as you need a second host, DRBD is free. The question is not how much does it cost, it's how much effort and complexity does it introduce, and does it give you a benefit for that? And in the case of, for example, your SQL server, while you could totally use DRBD, it would not give you the benefits you'd be hoping for, it would take them away. So you don't want to do it on a complexity basis, not that, saying it would act like the SAN and screw you over, right? So it's not like SAN is magic and screwing you over. DRBD would do the same thing if used in the wrong place. Okay. Our MSP quoted us an EMC SAN device to the tune of $25K so that the VMs could be migrated between the host with storage being on the SAN. So this is the trick. This is the 3-card Monty of SAN sales. Your server, the thing that matters is the SAN. In the case of your normal servers, it's your storage subsystem. So in the SAN, it's your remote storage subsystem. So the question is not, how do I migrate between the hosts? That's never a problem. That's easy. Right? Doesn't matter if you're independent servers, if you're replicated local storage, if you're a SAN, inverted pyramid of doom, none of that matters. Replicating or moving things between hosts is generally simple. You can find a way to do it. Even if you just have to go to backup and restore, not a big deal in most cases. The question is, what happens when your storage fails? When you're looking at your independent servers, we automatically say the server is going to fail. What fails? The drives, of course. Could be a fan, could be a power supply, could be a memory stick, could even be a CPU or motherboard. We all understand that it could be. It's not. It's your drives, maybe your RAID card, right? So we all, when we're looking at independent hosts, we instantly think storage, that's what's at risk. But when we put in a SAN, we're conditioned to say, SANs are magic, it'll never fail. But wait, it was only the part that we were worried about before. Now we're ignoring it? Why? Right, so the reason that we call it the inverted pyramid of doom is because it's shaped like this. There is redundancy, but it's on top, where when you're looking from the top down, you see redundancy. But it rests on a single point, the SAN, no redundancy. We don't look at the SAN unless you turn it on its side and look at it. If you're looking from the top, you have all this big, look at all that base. It must be powerful. It's so big. And then you turn it on its side, you're like, wait, it all rests on a single knife edge? That looks really risky. It is really risky. It could just topple, right? It has no support. So with the SAN, the question is, well, I don't care if the hosts die. I mean, I do, but not very much. All of the risk is in the SAN. And this is important. The SAN carries, if it was just a server, right? So don't go buy an EMC SAN. Just take a third server and make it a SAN. Magic, right? You have a SAN. That's all it takes. So you make your own SAN, and now you say, oh, that one SAN is every bit as risky as each of the hosts I was worried about before. I didn't solve anything. But now that SAN has all the risk I had before, but now I also have these hosts that they could fail too. That means my risk is bigger, not smaller. I just made it worse because 100% of my risk is still there. So the question is not how do you deal with the host failing, it's how do you deal with the SAN failing. Now EMC is going to say, oh, our SAN's magic, it can't fail, right? Which is what everyone says, right? Anytime you catch them, they go magic, right? They're going to tell you, oh, it's all redundant inside. Well, if it's all redundant inside, make my server redundant instead of my SAN and solve the problem, right? Well, you can't do that. Okay, then you can't do it with the SAN because it's all the same thing. What we found in the real world is that a lot of SANs, one, put in all this money, and the theory is you put in so much money into the SAN that it's really unlikely to fail. It's also a bad theory because it doesn't hold up in the real world. What we found in the real world is that most failures are human related, and SANs actually, because of all the extra complications, firsthand, I've seen $1 million SANs fail because they let a junior admin on them for a few minutes. Right? Did the hardware fail? No, hardware was perfect. The hardware deleted every single thing from the disks when the junior admin clicked the wrong button, as it was told to do. Right? Human error doesn't get fixed by having a SAN, but human error does get abated by not having a SAN. SANs are complex. Humans make mistakes with SANs. It's not SAN's fault, but it is the fault of who's selling them because they're trying to act like it's going to protect you. It doesn't. Then there's the problem that the SAN itself tends to fail. And we once managed to get Hewlett-Packard to state a statistic that basically said the SANs are the most dangerous thing ever. They said how many SANs they sold. We use that to combine it with how many sands of theirs we knew had failed, and just the sands that we knew had failed, compared to the number they had sold, was such a high number that their sands were failing, as we had suspected, much faster than their normal servers. How could this be, you say? Because it's all redundant, it has all this magic. Even though it's not magic, it's still like really expensive, cool stuff, right? No. The problem is, most sands have 2 nodes in them. It's just a 2-node cluster shoved in a box. The problem with a standard 2-node cluster is you need a witness. Maybe some of them have a witness, maybe some of them don't. But what often happens is the storage gets confused inside the box, and you get what's known as shoot the other node in the head problem, where one node thinks the other is failing, and they kill each other by sending kill messages saying, I'm in charge, I'm taking over, and they shut each other down. And the problem is that if something goes wrong, you lose both. So we call it the straw house problem, right? They pretend that these are 2 independent things, and they're really, really solid. And if one, we just go to the other, right? I got eggs, I got baskets, I'm good, right? And read my article on eggs and baskets, because it doesn't apply. But what it really is like straw houses in a windy day with a fire. Well, if the first house catches fire, it doesn't guarantee the second one's going to catch fire, but it really ups the chances, right? So if you live in one straw house and smoke, you have X risk of your house burning down in a year. If your neighbor also lives in a straw house and smokes and says, but you can come over in case your house burns down. You say, well, you can come over in case your house burns down. You say, we got redundancy, we're so safe. But your chances of one of your houses burning down is just as high as it always was, but the chances of both of them burning down is actually much higher than the chance of just one of them burning down originally. You've made it riskier because once one goes up in flames, the other is almost guaranteed to. That's what we find with sands. In laboratory testing, where you're very carefully yanking a node out, they almost never fail because the other node is gone. But in the real world, when a node fails, it puts crap on the line and isn't gone. And so in real world failures, we see sands dying at a really high rate. But in the lab, they can demonstrate how they're perfectly reliable when something goes wrong with them. They'll pull a node out, they'll put a bullet through a node. Yeah, those things kill it, absolutely. They shut off the power. That means that the existing node just has to take over the workload. That's not how real world failures happen most of the time. And so that concept that single thing is going to protect you actually becomes the riskiest thing you've ever imagined, right? Not only is and then the whole thing costs 3 times what it should. You only needed 1 node. If you're okay with that sand, you'd have been better with 1 server. No exception, okay? Cannot be an exception to that rule. That's math, right? You'd have been faster, cheaper, easier, less effort, less human error, and fewer parts to fail. Right? So if you can do with a SAN, you have guaranteed with no possibility of dispute that you are okay with a single good server well configured. Guaranteed and provable. Now, what you're suggesting is that you're not okay with a single SAN, and your VAR, your reseller, should have known that you came up with requirements that said a single SAN wouldn't do, but he proposed it anyway because he knew you wouldn't take 2 of them, so he's still trying to make his money without doing his job. So they tricked you with this question: how do you migrate the workloads? That is a smoke and mirrors. Look over here. Look at this thing that you feel. It's easy to make this feel risky. Ignore the actual risk. Ha ha ha. You don't care about migrating on the host. That doesn't really matter. You care about the SAN. That's where your risk is. Now, if you had replicated local storage, then you could migrate your workloads on the host, and if your storage dies, you'd only lose 1 host. Now, there's a reason to migrate, because now the device that you're worried about is the same place where you migrate. So that's sensible. How would you do it with replicated local storage? Well, with replicated local storage, each system sees it just like a SAN, right? It's basically a SAN. In both cases, SAN or RLS, it's just a clustered file system that attaches at block level. That's it. To the system, it's identical. Except one's faster, right? One has a network connection and one doesn't. That's it. And so then you can do anything you could do with the SAN, but without the risk of the SAN, without the cost of the SAN. Not that RLS is completely free, you still have to buy double storage. But if you wanted a SAN to have any kind of stability, it would need that double storage too. You just don't buy it because you know it doesn't matter, right? So every time we look at the SAN, you can say, well, you didn't care about it when you had this really risky thing, so now that we made it better, why would you care about it now? You shouldn't, right? So you're ruling out the SAN by the own arguments there. What would an implementation without a SAN look like if I wanted to maintain the replication? So SAN doesn't have replication, so you're not maintaining, you're adding replication for the first time. And the ability for the VMs to migrate between hosts. Again, you didn't have that availability with the SAN. You had a fake ability to do it. But it's as simple as implement DRBD, treat it like a SAN. And you get all the features you thought the SAN was giving you for free-ish. And that's about it. I think your answer here is unless I'm missing the thread, you do not want replicated local storage. You just want to implement your workloads correctly, have a good plan. 2 servers very possibly, but also very possibly not. Keep it simple. That is just a rule for everything, right? Don't over-engineer solutions. That's how the desire to over-engineer, which we all have, is fun, and it seems like it answers things that it doesn't, and management tends to like it because they only see the engineering, they don't see the math. That desire is what drives salespeople to think they can get away with SANs and stuff like that, right? And all of this, we're not even talking about what if that SAN had a switch. What if they tried to sell you a switch too? Now, you shouldn't. This is a 2-node cluster, it direct connects. But a lot of people will try to sell you a switch, and then of course the switch is a point of failure. Well, then they'll sell you 2 switches. Now we've got a switch which we could misconfigure or fail, another switch that could be misconfigured or fail, and the communications between them, which could be misconfigured or fail. And all the money of this, we got 5 things now, or 5 things. We're buying 2 switches, a SAN, and 2 servers, and we don't have anywhere close to the availability we would have with just a normal server, just a single, no failover server. And so much complication. And one of the reasons that they do this is not just to sell you 5 times what you need. It is certainly to sell you 5 times what you need, but also they want to make it so complex that you feel you don't want to deal with it, and that your management feels you can't deal with it, so they pay outrageous amounts of money for your MSP to come in and say, oh, we just happen to be the people who know how to do this thing. No one who's legit would know how to do it, because no one would. We'll take care of it for you. Of course, we're going to be $250 an hour, and it's going to take thousands of hours to do this because it's so complex, right? When someone being honest could come in and be like, nope, just put it in a server, it'll be done in 2 hours. Done, right? And now it's actually reliable. No, they're trying to sell a lot of consulting on top of 5 times as many nodes. And so keep it simple. That's where you get protection. Simplicity gives you speed. Simplicity gives you reliability. Simplicity gives you an avoidance of human error, not completely, but the most you're going to get. Simplicity gives you scalability in most cases. There's ways to scale very easily. Really, especially in what you're describing, there's no downsides to keeping this really simple. And only risk when you start implementing things like a SAN. That's where the risk comes from, right? If you just put in a single server, you could sleep at night. If you had a second server there, my gosh, what is there to even worry about, right? Even before you're talking about DRBD, any of that stuff, just rule it out. So I think a really simple, if this was me and I had no additional information, right? You have information I don't have, but given the workloads and what I think they are, I would implement Proxmox because that's what I like to use. It's KVM under the hood. Keep it simple. Has a web interface. Like, life is so easy. 2 boxes, yeah, I'm okay with that. Have good backups, and the workloads, SQL Server, for example, and some of this I exactly do, right? I have exact Proxmox SQL Server, double non-replicated storage. Like, this is how I run financials. And have your SQL Server replicate between the nodes. Make sure that is truly, truly high availability. Free PBX, just copy it every night automatically and have it sit. Also take a backup, don't stop backups. Just have a full image completely ready to turn on the second server, on the second Proxmox. Probably the same thing with inventory. Well, the inventory is have a database behind it. Only the database you have to worry about, right? Just keep a copy of the application. Just make sure the database is in both places. Can you put it on the SQL Server? What about the security system? Security system, who cares? Internal app, right? Should be going onto the SQL Server too, right? By convention, apps don't need high availability. They just need to be copied. They're stateless, hopefully. Your database holds all your state. So the only thing you have to worry about under correct circumstances is the database, right? File servers are a form of database, so that's, if you're like, but a file server, that's why, right? It falls under the database rule in a weird way. It's in the book. So that potentially you need to replicate in some way, but generally there's tools for that. Most, if it's Windows or Linux, I can't imagine what you're using that doesn't have something available or built in to do it. And in worst case, just do DRBD for that one workload. All the others, just copy the things, make sure your database is replicated, and you have such a good system that you can fail over any time with absolute confidence. You can practice failing over, right? And do that, right? That's good for you. And know that the whole system is something you understand, that you can service. You never need to call somebody. Everything makes sense. Everything is protected. Everything has a way to fail over if hardware fails. Everything can be backed up and restored properly, and there's no weird pieces that you aren't sure how it fits into the equation. There's no emotional gaps of maybe I needed something. Everything is covered. You can run the math, you can do the logic, you can run the chords. There's no extra pieces to buy, and take all that extra money and I don't know, throw a party for the IT department. All right, I hope that helps.